Hey, hello everyone, and welcome to this session on building streaming pipeline with Azure Databricks using structured streaming and Delta Lake. I hope you're enjoying the summit. In case you have any questions, you can feel free to put that in the chat panel, and I would be more than happy to answer your questions. All right, so it's time now to get started. A quick introduction about me. My name is Mohit Batra. I'm a founder at a company called Crystal Talks, which is into training and consultancy. I'm also an author with Pluralsight. So I have published few courses on Azure Databricks at Pluralsight. I am a Microsoft certified trainer, and prior to this, I worked at companies like Microsoft and Saxo Bank. In case you wish to get in touch, here's my LinkedIn profile on your screen, and you can get in touch, and I'll be more than happy to connect with you. All right, so let's see what is the agenda for today's session. So first of all, we'll do a quick introduction on Apache Spark. Now, this is not the place where we'll be spending most amount of time. It will just be a quick introduction on Apache Spark. Then we'll go ahead and talk about Azure Databricks, that how we can use Azure Databricks as a platform to build streaming pipelines. Then we'll talk about Spark Structured Streaming, which is a component of Apache Spark, and that will help us to build the streaming pipelines. Next, we'll talk about the architecture, that how we can build a unified batch and streaming pipelines. And finally, we'll talk about Delta Lake. Now, Delta Lake is one of my favorite components, and we'll see how we can use the Delta Lake to build reliable data lakes. All right, so this is the agenda for today's session. Now, what exactly is Apache Spark? I'm pretty sure you must have heard many times about Apache Spark, which can help you do big data processing. But what exactly the Apache Spark does? So Apache Spark is an extremely powerful in-memory analytics engine built on the cluster computing technology. Now, if you look at the keywords, it does the data processing in memory, and the memory is basically of the cluster on which it is going to perform the jobs. So it's an in-memory analytics engine built on the cluster computing technology. So this means that you can go ahead and install Spark on a single machine. That will act as a machine on which you can do the processing, or you can go ahead and install Spark on a group of machines. Now these machines will work together as a cluster and will help you do the data processing together so the data processing will happen on all these machines together. All right, so this is the Spark cluster. So you can start with single machine and you can go and scale up to thousands of machines. All right. So why should we actually use Apache Spark? Now, first of all, we should know that Apache Spark is an open source data processing engine that can help you do a lot of sophisticated analytics. It can help you do it with speed, and you can easily build your applications on top of it. So it's basically an in-memory engine, as we just talked about, and it can help you do 100 times faster processing than Hadoop, because it does the data processing in memory, while Hadoop is majorly oriented towards disk-based architecture. So it's a disk-heavy architecture that you go and write a lot of data to the disk. But in case of Spark, the data processing happens in memory. In fact, it is one of the largest open source data project, and it is very popular in the big data community. There is not just one language, you can write code in multiple languages. So you can use Scala, Java, SQL, R, Python, whichever language you are comfortable with, you can go and write your Spark code. In fact, these days there is support for .NET, which is also coming on Apache Spark. All right, so it's a pretty good engine that can help you do a lot of data processing. All right, so let's go ahead and see what is the architecture of Apache Spark. Now, at the heart of Spark, there is Spark core library that actually consists of all the Spark constructs, which can help you do, in fact, that can help you do in-memory processing. So as I mentioned previously, you can go and do the processing you can write the code in any of these languages, be it Scala, Python, SQL, R, or Java. On top of Spark Core, there are multiple libraries which are available. Like one of them is Spark SQL. So in case you want to do batch processing, or basically you want to build your ETL pipelines, you can use the Spark SQL library. If you want to do streaming, you can use a streaming library. If you want to do machine learning, so there is a machine learning library which is built on top of Spark Core, and you can use that to do machine learning. So that is what is called as MLlib. And finally, there is a graphics library. So if you want to do graph computation, you can use this particular library. Since we are going to do stream processing, we'll be using a library called Spark SQL. But why not streaming library? Because the streaming is available in two forms. You can use the streaming library, or you can use a streaming library present inside Spark SQL. All right, so this is what we are going to use as part of this demo. But there are several challenges that makes Apache Spark very difficult to use. Now, a lot of developers feel it's very hard to work with. The first and the foremost reason is the infrastructure management. Now, since Spark is just an engine, if you want to use it, you have to set up the infrastructure, you have to deploy Spark on top of it, you have to do the configuration, and then only you can use that. So that is why setting up the infrastructure in itself is a pretty big challenge with Apache Spark. As I just mentioned that it's just an engine, so that is why there is no native user interface available for Apache Spark. This means you have to get a separate component to build and write your applications. So that is why a lot of people use Jupyter notebooks as well to build code for Apache Spark. Then apart from this, if you want to upgrade to a newer version, now you went ahead, you deployed the Apache Spark on the infrastructure. Now suddenly, or in fact, after some period of time, you want to go and upgrade to a newer version of Apache Spark. This means that you have to redeploy Spark on all these machines. Now that is why the upgrade becomes a big challenge here. Now, apart from this, because again, it's just an engine, so you need to have separate tools for to do different stuff. If you want to integrate security, if you want to bring in the user interface, for all these things, you have to get different tools, and that adds to the complexity. And finally, because you'll be working in a team, so it's very difficult to collaborate on any project because there is no integrated environment which is available. So as I keep saying, it's just an engine that can help you do in-memory processing, but there are several challenges that you have to deal with. So to actually solve these problems, we have Azure Databricks. So what exactly is Azure Databricks? Now, Azure Databricks is an Apache Spark-based unified analytics platform which has been optimized for the cloud. Now, let me repeat this part. It's an Apache Spark-based unified analytics platform which has been optimized for the cloud. You can run it on AWS or you can run it on Azure. And as I said, it has been founded by the same set of team which actually created the Apache Spark project. All right, so let's see that now that we have Spark on Databricks, what are the features that you get from Spark when it is on Databricks? Again, it's in memory because it's again built on top of Spark, so it is in memory and you are allowed to do distributed processing of data. It has, in fact, the support for all languages which are supported on Spark, so be it Scala, Python, SQL, R, or Java. And in fact, it has the support for same use cases. You can do batch processing, you can do stream processing, you can do machine learning, or even advanced analytics. So whatever features that Spark provides are also available on Databricks. All right, sounds good. Okay, let's see then what is it that Azure Databricks brings to the platform. Now, first of all, as I said, Databricks can run on AWS and it can also run on Azure. But with Azure, it's a first-party service. This means you can get the unified billing, you get the first-party support from Microsoft. So all these things makes Azure Databricks a great platform. In fact, this Azure Databricks platform is basically a fully managed platform and you can run Apache Spark on top of it. If you want to set up the infrastructure, you just have to do a few clicks and it will go ahead and set up the infrastructure. So it is as easy as setting up a virtual machine on Azure. All right. Then if you want to write code, there is an integrated workspace which is available with Databricks. So you can write code along with your colleagues and you can do real-time collaboration. Now this makes it a very, very interesting platform because if you are working in a big team and you want to do collaboration with your colleagues on common set of code, just like you do it on any other project, you can easily do it on the Azure Databricks platform. All right. In fact, once you're ready with your application and you want to go ahead and deploy the application in production or you want to schedule it as a job, it also provides the facility of scheduling your code as a job. All right. So this is all built into the Databricks platform. Then Azure Databricks platform is fully integrated with Azure Active Directory, so you get the enterprise grade security on this platform. In fact, we'll see that in a demo that it is fully integrated with Azure Active Directory. Now then we have a whole bunch of optimizations which are available in Azure Databricks. So this means that if you deploy a native Spark in an on-prem environment, if you compare it with Databricks, Databricks can perform up to 50 times better than your on-prem deployments. So these are some of the features that Databricks brings to the platform, and with every few days there are new things that are getting released on the Databricks platform. So that is why it makes a very interesting platform to do your Spark based development. Make sense? All right. Now let's see that what are the different components which are part of the Databricks environment. So first of all, you have the workspace where you can go and write your code. In fact, you can do collaboration with your colleagues. Then there is the clusters or the pools. Now this is in fact, you can go ahead and set up multiple clusters. So this means that you can have one cluster with a different cluster configuration, and you can create another cluster with a different configuration. So you can point your code to any of these clusters to go and run it, which means that you can now run your code in different cluster configurations. Then there are notebooks in which you actually write your code. You can schedule them as jobs. Even in fact, you can create databases and tables, which will be pointing to the files present in the data lake. And finally, if you want to manage your machine learning models, that can also be done through the Databricks environment. All right, so these are some of the components of Azure Databricks which are commonly used. In fact, there are many more components which are coming up these days. So let's go ahead and see how you can set up the Azure Databricks environment, how you can create a workspace, how you can set up a cluster, and how you can create a notebook. All right, so I'm going to go ahead and move to the to Azure portal. All right, so you can see here I'm into the Azure portal. Now, if I want to create a Databricks workspace, I can go ahead and click on Add here and just provide some of the basic properties that are required to create any service, or in fact any other service in Azure. So I can just provide my subscription, select a resource group, I can provide the name of a workspace, select the region in which I want to deploy the Databricks environment, and then select the pricing tier. So pretty simple. I just have to provide some basic information to set up the Azure Databricks workspace. Now I already have a Databricks workspace defined, so I can show that to you. So I'll just go here, and you can see that I have few workspaces which are defined here. Now I can go to one of the workspaces, and then I can go ahead and launch the workspace. Now when you will launch the workspace, and you will see that it is going to go ahead and sign in with Azure Active Directory single sign-on. And that is why I said that it is fully integrated with Azure Active Directory. Now what you see here is the Azure Databricks workspace. The next thing, as I said, we can go ahead and create a cluster. So I can go here to the clusters tab, and I can go ahead and create a cluster. So I already have a running cluster, but I can show you that what are the things we need to do in order to set up the cluster. So I can click on create cluster. I can provide the name of the cluster. Then I can go ahead and select a Databricks runtime version. So you can see there are different Databricks runtime version. So there is Databricks runtime version 7.4, then there is 7.3, and there are other versions as well. Now, what exactly is Databricks runtime? Now, Databricks Runtime is a set of pre-configured libraries that you can install on the cluster. So if you want to have a specific version of Spark, or if you want to have a specific version of Scala, Python, and even some commonly used libraries, you can select one of the runtime, and these libraries will be installed on the cluster. The great part about all this is that all these libraries are compatible with each other. This means there is no headache for you to manage the infrastructure. You can select a Databricks runtime version, which is pre-tested by the Databricks team. And once you select it and create the cluster, these set of libraries will be installed on the cluster. All right. So what you see here is I can also go ahead and enable auto scaling, which means that anytime my load increases, it can go ahead and auto scale my environment. And the very good feature here, which you see, is the termination option, which means that if there is no job which is running on the cluster, I can put up, I can select the time after which it will auto terminate. This means if there is no activity happening on the cluster, let's say for 120 minutes, automatically the cluster will terminate. Now this can be a huge cost saver. So I can, in case there is nobody who is working on it, after 2 hours, it will auto terminate. So you can specify the number of minutes after which you would want to terminate the cluster. All right, so once you select these options, you can just create the cluster. And in fact, I already have a running cluster here, which is running on version 7.3. So this is the Databricks runtime 7.3, and it will install Apache Spark 3.0.1 along with this. All right, now after you create the cluster, you can go ahead and create a notebook where you can write the code. So to create a notebook, I can go to the workspace environment. And this is where I can go and create a new notebook. So let me just go ahead and create a notebook here. And I can provide it's the DPS demo that we are doing. And then I can select the language in which I want to write the code. Now remember that this is only going to be the default language. And in the same notebook, I can write code in multiple different languages, right? So you can see it's the options which are available is Python, Scala, SQL, and R. All right, and then you can run it on any cluster. So if you have multiple clusters, you can run your code on any cluster here. All right, so I'll just go ahead and create this notebook, and now I can start writing my code from here. So this is just a quick introduction of how you can set up your Databricks workspace, how you can create a cluster, and how you can set up the notebook. All right, so let's switch back to the slides. Now let's talk about what is Spark Structured Streaming. Now, as I said, Spark Structured Streaming is a component of Apache Spark using which we are going to build our pipelines. Databricks is just a platform where I can write the code, but the code will be written in using Spark Structured Streaming. All right. So back to the Apache Spark architecture. So as I mentioned previously, if you want to build streaming applications, you can use Spark SQL library. Of course, you can build your applications using streaming library as well, but here we'll be using Spark SQL library, which provides us with Spark Structured Streaming. All right, so what exactly is Spark Structured Streaming? So Spark Structured Streaming is a scalable and fault-tolerant stream processing engine, which is built on the Spark SQL library. All right, so let's go ahead and look at the different components of Spark Structured Streaming and how it provides us the environment to build the streaming pipelines. So first thing, or in fact, the first component that we have is the streaming source. Now, let's assume that there are some events which are continuously arriving at the source. All right, and this source is something that can be a stream ingestion service like Azure Event Hubs. Now, each event that is arriving at the source is actually assigned an offset by the source. So the source should have support for offsets. All right, so this is a mandatory requirement for a streaming source that it should have support for offsets. Now, these offsets, it actually helps to track the current read position at the stream. Now, what does this mean? That it actually helps to track that till what point we have actually read the data. And next time when the application runs, it will pick up the further data based on the offsets. So basically, as I said, these offsets are helping you track the current read position in the stream. Now, it is also very helpful when there is a failure. So in case of any failure, it can go ahead and re-extract the data back from the source based on these offsets. And that is why the streaming source should be replayable, which means in case there is a failure, it should be able to extract the same events based on the offsets. All right, makes sense, everyone? So that is the first component, which is the streaming source. The next one, or in fact, the next component here is the unbounded data set. So what exactly is unbounded data set? Now, first think about that whenever you are doing batch processing of data, you extract, let's say, some data from the source, let's say from a file. Now, once you extract the data, this is the static set of data that you are actually working with. This is what is called as a bounded data set. Now, where you have a defined boundary. All right. Now, whenever you are working with streaming data, what happens is the records are continuously coming in and they are getting added to the data set. Now, this dynamically changing data set that you are seeing here is what is called as an unbounded data set. Now, that is why the new events that are coming in, they are actually getting added to the data set. Now, if you carefully notice that now when you run a query, or in fact, first time when you run a query, you are running on this first data set. All right. Next time when you run the query, it is on a change data set. So if you have carefully seen here, every streaming execution, it looks like it's a batch execution. So first time, this is the batch on which the query is executing. Next time, this is the whole set on which the query is executing. So that is why the streaming execution looks like now a batch execution. And that is how the structured streaming works. All right. And this is internally the complete data set that you are seeing here. This is internally is called a streaming data frame. So you have a batch data frame just like this on which you do batch processing, but then you have stream processing happening on the streaming data frame. Sounds good? All right. Now let's go ahead and see what is the query for structured streaming. Now it's a typical ETL query that you write. Now, first of all, we'll go ahead and extract the data from the source. So to extract the data, you will use the spark.readstream API, and then you can provide the format, or in fact, you can provide the source from which you want to extract the data in the format. Now, this will create a streaming data frame called input.df. Next, once you have extracted the data from the source, you can now go ahead and transform the data. Just like you do an ETL transformation, just like you do transformations in your ETL rather, you can go and transform the data by, let's say, doing some filter by using the where clause. Or if you want to create a derived column, you can use the with column method. Or if you want to select limited columns, you can use the select method. So there are so many different methods in using which you can do the transformations. Now, once you do all these transformations, it will again create another streaming data frame. All right. Now, once you have the streaming data frame with all the transformations done, now you can go ahead and write this data to a sink. Now, to write the data to the sink, you can use the result df, which is the streaming data frame, and then you can use the write stream API. Now, once you use the write stream API, and then you can go ahead and provide the format. In the format, you can specify the type of sink. So I can say the format could be a data lake, it could be a SQL server, or it could be any other database in which I want to save the data. So there are different formats which are available where you can store the data. Now, this particular query will not run until and unless you use the start method. So as soon as you run the start method, the stream will start running. It will extract from the source, apply the transformations, and then go ahead and load the data. Pretty simple, right? All right. Now, this is what is the query for structured streaming. Now let's understand how actually the execution works. So basically, Spark run queries using a micro batch processing engine at specific trigger intervals. So let's see how that works. Then let's assume we specify a trigger interval of 5 seconds. So if you have 15 seconds, the first trigger interval will be from 0 to 5 seconds. The second interval will be from 5 to 10 seconds. And the third interval will be from 10 to 15 seconds. So this means the execution that will happen, it will happen at the end of every trigger interval. So it will happen at the 5th second, 10th second, 15th second, so on and so forth. Now let's say there are some events getting added to the source. Now the first trigger will actually happen at the 5th second, right? Now at this point, when the first trigger runs, it will extract the data from the source like E1 and E2. Now these two events, E1 and E2, will be the part of micro batch 1. All right, so this will be your batch on which the processing will happen. So the data will be extracted and that will be processed. Now at the second trigger, which will happen at T2, so there are 3 more events, E3, E4 and E5. So these 3 events will be extracted from the source and they will be processed. This will happen this will be called as micro batch 2. All right. So in the same way, at the third trigger, which is T3, E6 and E7 will be extracted from the source and they will be processed as the part of micro batch 3. So this is how the micro batch engine processes the data. So you can see that at every trigger interval, whatever new records are available, it will just extract that data and then process it. And that is how it runs the streaming applications. All right. Now let's see how the end-to-end execution works. Now, if we take the previous example, let's say there are events which are coming in the source. Now, at the first trigger, which will happen at the 5th second, if you have a trigger interval of 5 seconds. So the first trigger will happen at the 5th second. Now, at this point of time, as you know, E1 and E2 will be extracted from the source. All right. And these two events will become part of the input table, now which is also called as unbounded data set. All right. Now on this input table, let's assume that we are running a query where we want to filter the records. All right. Now on this input table or the unbounded data set, the Spark will go ahead and run the query execution plan. All right. So once the query runs on this input table, now this input table is in memory. And once you run this query execution plan on this input table, it will go ahead and give you a result table. Now again, the result table is also in the memory. Now what will happen? This result table will be saved to the sink. All right. So let's say there is only one record that is there in the result table. This particular record will be saved to the sink. All right. Now, what will happen at the second trigger? So let's say there are three more events, E3, E4, and E5. So the second trigger will happen at the 10th second. At this point, only the records E3, E4, and E5 will be extracted. Correct? But now the input table will have the old records, E1 and E2, plus it will have these new records, E3, E4, and E5. And that is why, if you carefully notice, this is what is called as an unbounded data set. Does that make sense? All right, now that we have this full input table, again, Spark will go ahead and run the same query, let's say doing some filter. All right, so once you apply the filter, in case the old records also needs to be processed again, it will pick it up and process that, or totally depends on the query that you are executing. If that is required to be processed, it will be processed again, or otherwise only the new three records will be processed. Now, once it processes the data, let's say there are, these three records passes the filter criteria. So you have again the three records coming in, but the result table will have the old records as well. All right. Now, depending on how you want to save the data, let's say I'm only looking for new rows. All right. So I'm specifying here append only option. So only the new rows which are coming in the result table, I'm going to take it and store it in the sink. So just like you have the option of append only, you can also have the option of update, or if you want to get the full result table as an output, you can also get that. All right, so this is how the execution is happening. Let's see it one more time. So let's say the E6 and E7 are the new records that have come in. Now at the third trigger interval, these two events will also become part of the unbounded data set or the input table. And again, it will run the same query execution plan on top of it. And whatever is the output that is coming, it will contain the previous records in the output table as well as the new ones. And since I'm using the append only option, it will go and save the new records in the sink. And that is how the structured streaming processing model works. So what is structured streaming processing model? Basically, it runs the batch-like queries on the streaming data. And that's what we said, that you have an unbounded data set where it is running batch-like queries on the data set. All right, so it is running the batch-like queries on streaming data using incremental execution plans. And that is the processing model of Spark structured streaming. So now let's see what is the scenario that we are going to implement here. Now let's assume that there is some taxi rides which are going around. Now let's say the every cab has an application or a device installed. Now whenever a ride will start, it will generate an event, and whenever the ride will complete, it will generate another event. All right, and these events will be sent to a stream ingestion service like Azure Event Hubs. All right, so these events like the ride start event and ride end event will be stored in Azure Event Hubs. Now once the events are there in the Azure Event Hubs, you can go ahead and run the stream processing, or basically using Spark structured streaming, and you can go and extract the data from event hubs, and then you can process the data by using the same ETL query that you just saw. All right. Now, once you process this data, you can then go ahead and store this processed data into variety of sinks. Now here we are going to store the data into Data Lake Gen 2. That will be the processed data. And of course, you can go and visualize that data into Power BI. But here in this demo, we'll not be using Power BI. We'll just go ahead and push the data into the data lake. All right, so this is a streaming scenario that we are going to implement. So let's see that how we can build the streaming pipeline. So first of all, we'll configure Azure Event Hubs. Then we'll run a sample application to push the data to Event Hubs. And then we will process the data by extracting from Event Hubs and storing it into Data Lake. All right, so let me just switch over to Azure portal. And you can see I already have an Event Hub namespace defined. All right, so we are going to use this Event Hub namespace, and I'm going to push the data to an Event Hub. All right, so we'll need to copy the connection string and I'll need to copy the name of the event hub in which I want to push the data. All right, now if I want to configure this event hub in Databricks, I'll need an open source library to be installed on Databricks cluster. So let me show you that there is an open source project which is the Azure Event Hubs connector for Apache Spark. Now this particular project is hosted on GitHub, so you can go and have a look at this project. Now, if you want to install the Event Hubs connector, which is for Apache Spark onto Databricks cluster, you can see that there are various libraries which are available. So depending on the version of Spark or depending on the version of Databricks, you can install this library. Now, since we are going to use Databricks Runtime 7, you can see that here is the library I can go and install. And this particular library is hosted on Maven Central repository. All right, so if I click on this link, Maven Central. Now, Maven Central is a centralized repository for keeping all these kinds of projects. All right, so you can see here that I'm inside the Maven Central repository. Either I can go ahead and download the jar file and I can install it on the Spark cluster, or I can go ahead and use these Maven coordinates which are available for this project. So I can just go ahead and copy these coordinates and then I can use this to install the library on the cluster. Now, once I copy these coordinates, I can go to the Databricks workspace and I can go to the cluster. So I have the one cluster which is available. I can go to this cluster, switch over to the libraries, and now it's already installed, but I can show you the process of how you can install this library. So in the libraries, you can click on install new, and then you can go ahead and point to the Maven repository where the library is present. So I can go to the Maven tab and there I can paste the coordinates. So once I paste the coordinates of the project and click on install, it will go ahead and install the library on the Spark cluster. So you can see here the library is already installed on the Spark cluster. Now that the library is installed, let me go to my application code. So I already have a notebook saying structured streaming with Delta Lake. Now let's go ahead and start running the code and see how we can extract the data from event hubs. All right, so first of all, I'll just go here and configure the event hubs. So you can see here, I have specified the namespace connection string of Azure Event Hubs, and then I have specified the name of the event hub from which I'm going to extract the data. All right, so I'll just go ahead and set up the Azure Event Hubs. All right, so it is done now. Now I can go ahead and extract the taxi rides data from the event hubs. All right, so you can see here I'm creating a streaming data frame which is ride input df. So I'm going to use the same API that you saw on the slides. So that will be spark.readstream, and then I provide the format, or which is basically the source from which I want to extract the data. So in this case, I have specified event hubs. All right, then I have provided the event hubs configuration, which includes the namespace connection string and the name of the event hub. And then once you run this, it will go ahead and create this streaming data frame. Now let's see what is the data which is there in this streaming data frame. So I'm going to use a display function which is available in Databricks, and I can see what data is going to come in the ride input df streaming data frame. All right, so let me go and execute this. And the stream is initializing. And right now you can see that there is no data which is available here because so far we have not pushed any data to event hubs. Now I'm going to start a sample application which is going to push the data to event hubs, and then this application, in fact this code, will be extracting the data from event hubs. All right, so I'm going to start an application here. So I've already created a small application which is going to send out the taxi ride events. Now this particular data I have picked up from the NYC Taxi and Limousine Commission's open data release, and I have modified it for this particular demo. So I'm going to start this particular .NET application, which is going to take the event one by one, whether it could be a pickup event or it could be a drop event, and then it is going to push the events to the event hub. And you can see that now it is sending out the events to event hubs. So P signifies these are pickup events and D signifies these are drop events. So at every second, what are the pickup and the drops which are going on, this information is being pushed to the event hubs. All right, so if I go back to the Databricks workspace, you can see that now it is going to pick up the data and it is showing up here. So every 5 seconds, it is going to pick up the data from event hubs. Now, first of all, I can see here that there is no taxi ride event which is showing up. So this is the format in which the event hubs provides the data. The actual taxi ride data is in the body column, which is in the binary format, and rest of the attributes that you see here are the attributes of event hubs. All right, so let me just stop the query here. All right, now that you see that the data is in the binary format, first of all, let me define the schema for it, which will help me extract the data from the body column. All right, so I'll just create the schema. And what you see here, I'm creating the ID column, the event type, which means that it is a pickup event or a drop event. Then what is a pickup time, pickup location ID, and then we have the drop time, drop location ID, and all the other information. All right, so I've defined the schema. Now what I'm going to do, I'm going to apply this schema on the body column. So first of all, on the body column, I'm going to cast it as a string. So it's in binary format. So I'm going to cast it as a string, and then I'm going to apply the write schema that we have just defined. Now from the JSON format, now once this string data comes, which is in JSON format, we are going to apply the write schema, and this will go ahead and now give me the data in fully JSON format. All right, so I'm going to apply this function from JSON, and this will convert this string data into JSON format. Now I'm just going to name this column as taxi data. And then once I have this taxi data column, which is JSON format, then I can go and extract all the data, or in fact, I can extract all the attributes from this JSON format. So JSON format has got columns like ID, in fact, attributes like ID, event type, pickup time, cab license, driver license. So I'm going to extract these columns from the JSON format. So this is the code that I am defining to first go ahead and take the binary data, convert it into string, from the string convert it into JSON, from JSON convert it into the columns. So you can see here, this is a streaming data frame, and it has got now these columns. Make sense? Now what I'll do, I have this write df data frame. Now I can again run the query and see what is the data that we are getting here. All right, so now you can see here that there are few pickup events coming up, and there are some drop events which are coming up. If it's a pickup event, it will have information like pickup time, cab license, driver license, the location ID of the pickup, and some other information. But if it's a drop event, then you will have information like drop time, drop location ID, the trip distance. In fact, it just kind of got refreshed. So you'll have the information like drop time, you'll have the drop location, you will have the trip distance, the payment type, and the payment amount. So all this information is now flowing from the taxis to event hubs. From the event hubs, we are picking up the data using Spark structured streaming, and we are showing up the data here. All right, so I'll just stop the query here. Now, once I have this data which is coming in, I can even go and save this data to the data lake. All right, so to store the process data in the data lake, what I need to do, I need to use a streaming data frame. I'm going to use the write stream API. Then I'll define that in what format do I want to save this data. So I'm defining here that I want to save this data in CSV format. Then I can go and define the location on which I want to store the data. So this one is the mounted location of a particular data lake, and I'm going to store the data in writes streaming folder. All right, so the trigger interval here will be 10 seconds, and then I'm going to run the start query. All right, so once I run this, it will now pick up the data from the streaming source. It is going to process it and store this data into data lake. Pretty simple, right? All right, so let me stop the query here. And now what you have seen previously, that there are if there is a pickup event, you're getting other columns as null, like the drop time and drop location. If it's a drop event, then the pickup time and cab license information is null here. All right, so now let's talk about the architecture. Then in case you want to build a unified batch and streaming pipeline, what do you have to do? Now think about, this is the same architecture that we have just implemented. Now, in case I also want to build the batch pipeline, what do I have to do? There might be some static data or historical data which is available in the form of files. Now, I would want to store this historical data into data lake. Along with that, I would also want to store the data which is coming from event hubs, because that is the streaming data we are processing, but still I would want to use that data to do batch processing. Now, once I have this raw data into the data lake, I can now go and again use Spark, but this time to do the batch processing. So Spark can help me do batch processing. It can help me do stream processing as well, right? But this time I'll do the batch processing. And once this batch processing is done, I can then go and store the data into again data lake. But this time it will be a separate set of files in which I'm going to store the process data. Now, once I have this batch process data, again, this data can also be used by Power BI. So we are now going and getting the separate views of streaming data, and we have separate views from batch data. This type of architecture is what is known as Lambda architecture. All right, so it's a typical Lambda architecture where you have separate views of streaming data and you have separate views of batch data. But there are several challenges that are associated with this. If you carefully notice, we are doing the reprocessing of the data. So we have already processed the data in the streaming fashion, which is coming from event hubs. We have processed that using Databricks, and we have stored it into data lake. But then to do batch processing, we had to re-extract the data from event hubs, maybe using another Spark job. We have to re-extract that and then store it in the raw format in the data lake. And then we are taking that raw data and doing the batch processing. This is because when you are doing stream processing, and let's say you want to merge the records, can I do that? The answer would be no. This means that updates and deletes on data lake is not such an easy job. So that is why, because streaming, we cannot wait for merging the data. That is why we do all these kind of merge during the batch processing. All right. So these are some of the limitations of Lambda architecture. And that is why if you are working with data lakes, you will see these issues. And this is where people go with data warehouses so they can get rid of these problems. So this means if you want to do updates, deletes, or merge on the data, this is very difficult with data lake, but you can easily do that with a data warehouse. Also, there is a consistency problem. This means that if one process is writing the data into files and the other process tries to read the data from the same set of files, it can create consistency challenges. All right, so the reader may not get the consistent view of the data. Then in case you want to, in case there is a failure or if there is an issue with the data, if you want to roll back, it is very difficult to do with a data lake because you have overwritten the files. Now, a typical scenarios that you implement with a data warehouse, like the change data capture or slowly changing dimensions, it's very difficult to do with data lake. And that is why there is a new component called Delta Lake, which can help us solve these problems. So what exactly is Delta Lake? Now, Delta Lake is an open source storage layer that can bring reliability to data lakes. Now, what does that mean? We'll try to understand with the help of architecture. All right, so it's an open source component which was first developed by the Databricks team, and now it is a fully open source project. You can go and install it in the on-prem environment, or you can use it with Databricks. All right, and this helps to bring the reliability to our data lake environment. So let's bring back the Lambda architecture that we talked about. So we have a separate streaming pipeline, which is having separate views of the streaming data. And then we have the batch pipeline, which is creating separate views of the batch data. Because there are differences between the two, like you might have to merge the data, you might have to do updates, you might have to do deletes. All these kind of things are not possible with the streaming data, or in fact, when you have streaming data putting into data lake, it's not possible to do that. That is why you create separate views for batch. Now, what you can do with the Delta Lake, you can go and combine the data from the streaming data source as well as the data from the batch data source. All right, so you can combine them all together and you can get most of the features that you get from a data warehouse. So what you can do here, you can extract the data from event hubs, you can process it using stream processing, and then you can store it into Delta Lake. You can also extract the raw data from, let's say, from files or some other place. Then you can do batch processing as well, and then store it into the same tables in the Delta Lake, which means you can use the same set of files to store your streaming data as well as batch data. And this means that we still have to work around with the consistency, think about the slowly changing dimensions, change data capture scenarios. All these can be implemented with Delta architecture using Delta Lake. And that's what I refer to as the Delta architecture. And using the Delta architecture, and in fact using the Delta Lake component, you can go and combine that data. Now let's see what are the features of Delta Lake. First of all, you can get a unified source for the batch and streaming pipeline. So you can extract the data from that unified source. Along with that, you can have a unified sync for batch and streaming pipeline. This means that one pipeline, let's say the streaming pipeline is continuously writing the data, and on the other side, the batch pipeline can also write the data in the same files. This is what you get with Delta Lake. So this means that one part of the process might be writing the data, the other part might be reading the data. So you can have a unified source and the sync for the batch and streaming pipelines. So along with that, it also provides with asset guarantees. So this means that you get a fully consistent view of the data. So let's say the streaming pipeline is writing the data and the batch pipeline wants to read the data. The batch pipeline will still get a consistent view of the data. This is because the Delta Lake provides us with asset guarantees on top of the data lake. So if there are multiple pipelines, as I said, if they are reading and writing at the same time, they will get the consistent view of the data. Now, along with this one, you can also go ahead and do the updates, deletes, and the merge in the data lake. Now, this makes it very, very interesting. Now, this means that you can do all these operations on top of a data lake file. So you have a file, and in the file, you are going ahead and doing the updates, deletes, and merge. All right. Now, the next part is the Delta Lake also allows you to do schema enforcement. So this means you can define the schema of a file, and in fact, you can enforce the schema on the data lake. These are the typical things that you do in a data warehouse. And now with Delta Lake, you can do the same thing on a data lake. It also allows for schema evolution. This means that in case you want to add new columns into the Delta Lake table, you can also go and do that. So this allows you to gracefully make any changes to the table schema. Now, then we have the audit history as part of Delta Lake. So which means that whatever changes are happening on the Delta Lake, it keeps a track of every change. So if you want to go back and track that who made a change, at what time a change was made, all that audit history is also available in Delta Lake. And finally, one of my most favorite features of Delta Lake is the time traveling. So this means not just audit of the data like who made the change, you also get the full version of the data available. So you have a version of the data available, and using which, in case you want to do a rollback, you can also roll back the changes. So if you carefully notice, the Delta Lake is also providing you with all kinds of features which are available in a data warehouse. So you can go and get the asset guarantees, you can do the updates, deletes, or merge, you can make any changes to the table schema, you can enforce the schema, you get the changes like who made the changes, so that is available from audit history. And in fact, there is a versioning of the data which is also available, so that can help you roll back in case of any issues. All right, so this is what are the features which are provided by Delta Lake. All right, so let's see how the Delta Lake works. So first of all, we are going to set up the Delta Lake as a streaming source. We are going to extract the data from the streaming source for a batch pipeline. We are going to go ahead and merge the data into the Delta Lake table. So that will act as a sync, and then we can check the time travel as well. All right, so let me go ahead and switch back to the Databricks workspace. So back to the Databricks workspace. Now, first thing that I'm going to do here is I'm going to go ahead and create a table. Now you can see here carefully that I'm using a Python notebook, but I'm going to write the SQL statement. So if I want to write the code in any other language, I can go ahead and use a percentage symbol, and then I can provide the name of the language. This particular thing is also called as a magic command in Databricks. Now what I'm doing here, I'm going to run a SQL statement. So I'm saying create or replace the table, which is the writes table, and then we are defining a write ID, and then the other columns like pickup time, pickup location ID, cab license, driver license, and even the drop based attributes. And you can go ahead and keep any data types for these columns, but I've just went ahead and kept it as string. Now, once you define the table structure, you can say that this table is going to be of delta type, and this will be the location of the delta table, which means that this is my location of my data lake, and this will be the folder in which I'm going to store the data. So basically you are providing the location of the data lake, and you are saying the format of this table will be delta. All right, so let me go ahead and create this table. Now what it will do, it will go ahead and create a file at this location. It will be a format delta, and this will be the structure in that file. All right, so I can see here that the struct table has been created. Now I can go ahead and start putting the data into this Delta Lake. Now, first of all, because we have a streaming job which is running, I'll just show you that again, we are going to use the write df, which is basically contains the data for the pickup events as well as for the drop events, right? So they both are coming as separate events. Now we are going to use the write stream again, which is going to write the data to the underlying sink. And then we are going to say that for every micro batch that is going to execute, I want to call a function. All right, so I'm going to create a function and I'm going to call this function on the execution of every micro batch. All right, and the trigger interval again is 10 seconds, and I'm going to update the new data. Now, what is it that I'm going to do here? Now, I'm going to define this function and see what we'll do here. So here is the function, write event to delta table. Now, what we'll do here, first of all, whatever is the new micro batch that is coming. All right, so whatever is the new micro batch coming here on every 10-second execution, we are going to create it as a temporary view in SQL. All right, so we are going to create a temporary view with the name updates. All right, so this will be the new table called updates, where we'll have the micro batch data. Now what we'll do here, now we are running a SQL query. So you can see here, I'm using a command called merge, or in fact, there is a SQL statement I'm going to create with the merge. So I'm going to merge into the writes table, which is my target table. And I'm going to use the updates table, which is the updates view, and this will be my source. I'm going to join both of them on the write ID. So you can see the updates table will have a ID column, and I'm going to join on the ID here, and the writes final table, which is my delta table, I'm going to use the write ID. So I'm going to join these two tables together. And in case there is the event type is of type P, and it is already available in the delta table. So the statement says when matched, which means the write already exists in the table, and the event type is of type P, which means it's a pickup event. So I'm going to go ahead and update the pickup attributes. All right, but and in other case, if the write ID already exists in the writes table and the event type is of type D, which is the drop event, then I'm going to update the drop attributes. So what you see here, we are going to update the rows in the Delta Lake table. And finally, if the record does not exist in the Delta Lake table, I'm going to insert the records. So what we see here, it's a typical SQL query. And if you're coming from SQL background, you'll find that you might have seen this syntax many times. So we are doing a merge on the main writes table by using the updates table in case the write ID already exists. So we are going to update the attributes. And if the write ID does not exist, we are going to insert the records. So let me go ahead and create this function. And once the function is created, now I can go ahead and start running this query. Now in this query, at every micro batch, this function will be called, and then we're going to update the data in the Delta Lake table. All right, so I'm going to start the query here, and I'm going to restart my sample application on the other side. So here I'm just restarting my sample application, and it will again start sending the pickup events and the drop events to the streaming application. Right, so you can see here there are pickup events going on and there are some drop events which are going on as well. All right, so now there are more pickup events, which means the writes are getting started. All right, so back to the workspace, and you can see now the query is going on and the data is getting added to the Delta Lake. Now, how can I verify that the data is getting added? First of all, note here that it is writing the data. Simultaneously, I'm going to read the data from the Delta Lake table. So I'm going to run few queries here, which are SQL queries. So I'm going to read from the writes table. And in case the writes have started, then I'll have the pickup time, which is not null, but the drop time will be null. And then if the write is completed, the pickup time will be not null and the drop time will also be not null. All right, so I'm going to run this query. So on one side, the data is getting written to the Delta Lake table. And on the other side, I can see that I can read the data as well. So this is going to give me consistent view of the data. All right, so there are continuously getting records getting appended to the table, and now we are also reading from the Delta Lake table. I can immediately go ahead and convert this to a chart as well. And now I can see that how many records, in fact, how many writes have started and how many writes have completed. All right, so this is what I'm reading live from a Delta Lake table where we are updating the records. Pretty interesting, right? Now, along with this one, I can also show you that how we can look into the previous versions of the data. All right, so I can go into the data tab and you will see that there is a writes table which has been created. So I can click on this one. So this is the schema of the table, and this is a schema that will be enforced. If I try to put data in any other format, it will actually reject the data. All right, and you can see this is a sample data. There are some writes which have started, but they have not completed yet. You will also see that as soon as a write has completed, it will show that there will be drop time as well. All right, so if I go to the history tab, so I can see these are the number of versions. You can see here, these are the number of versions that have been created on the table. At any time I want to get the previous version, I can use the previous timestamp and then I can extract the data. So you can see that Delta Lake can help you move away from the Lambda architecture, combine the streaming views and the batch views together under Delta Lake. And that's what we call it as a Delta architecture. All right, so that is it for today's session. I hope you enjoyed the session. Special thanks to Microsoft for supporting this community initiative. And we would like you to provide your feedback for this session as well as for the conference. So that's it. And if you have any questions, feel free to put that in the chat panel. I am still available and I can help you answer your questions. So thank you and have a good day and continue learning at the Data Platform Summit.